Section 10.1 has us dealing with the square root property, which is also known as the extraction of roots. This has to do with working with and solving quadratic equations, and we're using it in a fairly niche scenario showing up here. So our main goal, more than anything else, is to, with a given quadratic equation, we're going to be solving it for a given value. Now, as you've done with the previous videos, I recommend taking a moment and pausing it to take a note of these and write them down for yourself. We are going to go through them in a bit more detail, but I think having the process in front of you goes a really long way as you're going through these problems. So the first step in our process is to isolate the quadratic term to one side. This is going to be where we're looking for an x squared or an n squared or z squared, something like that. We're trying to get that all by itself. To make this happen, we are going to be adding or subtracting terms from both sides of the equal sign as necessary. More often than not, we're going to have to add or subtract one thing, add or subtract something else, and then we'll eventually get to that point. After we've done that, we want to then eliminate any and all coefficients of the quadratic term. This means any number that's multiplying or dividing with that x squared or n squared or anything like that. We want to get rid of that. Our main tool that we're going to use to make that happen is that we are going to be multiplying or dividing. That all depends on the numbers that we've been given and what operation that they are doing with that actual quadratic term. Once we have that x squared or n squared or whatever it is, all by itself, we are then going to apply the square root property, which is really just a fancy way of saying that we are going to take the square root of both sides of this equation. That's going to get rid of some x raised to the second power. I mean, we're going to have just an x or an n or a z, or we're just going to have that variable left over on that one side. Now, it should be noted that when we do this, we absolutely must remember that because we are bringing the square root into the equation, we must include both possibilities when it comes to the numbers on the other side. It could be a positive number or a negative number, and so therefore we need to include what's generally referred to as the plus minus sign. So we will get to how to work with that in the next step, but we need to make sure that because we bring the square root in, we have to have plus or minus. It's a non-negotiable thing that we need to have showing up in these problems. When we get to story problems later on, if you forget to do that, it can cost you points on problems and give you a lot of errors showing up in that regard. So after we've done this, we then simplify the resulting radical or radicals that can sometimes show up with this. Now, radical notation is perfectly acceptable for most of your answers, but make sure you're double checking with your instructor and or double checking with what the problem states is okay to use for your final answer. More often than not, it's okay to leave something like the square root of 75, even though for my particular class, we want to leave something in this more fully reduced form, 5 root 3, like we did back in chapter 9. But it could be the case that maybe your particular problem or your instructor says, you know what, when you get to this point, you can skip going to this step. You can rewrite that thing as a decimal. Make sure you're double checking with what the directions say to go through, and make sure you're answering it accordingly in that regard. And then once we have that, we've gone through, we've found our potential answer or answers, we need to then check those in the original problem and make sure we have the correct thing showing up there. A lot of people do not want to do that check step, and while it can be a little bit tedious from time to time, it does tend to give us the best results and let us know, hey, I do have a correct answer, or I can use this answer, or in some instances let us know, hey, I can't use this answer, but I can use the other one. A lot of the times that comes up with story problems where we'll get a positive answer and a negative answer. And maybe it has to do with time. We're asked about how long does it take for something to, let's say, fall from the top of a building. You threw a hammer off the top of a building or something like that. How long would it take for that thing to hit the ground following a quadratic equation? Well, it wouldn't make sense to have a negative time, but it would make sense to have a positive time. So make sure that you are checking your answer in the original problem to see that it actually makes sense with what the problem is asking you. Last but not least, and this isn't always something that shows up, but it does happen just frequently enough, if necessary, make sure that you are going back and rewriting parts of the equation. More often than not, we're going to be using special products like the square of a sum or square of a difference to make that happen. If you need a reminder in terms of the other videos, this was covered in the section 7.4 video regarding how to factor things into the square of a sum and square of a difference. So I'd reference that video if you need to. Now for our examples with these, we have two main types of equations that we are going to primarily be seeing showing up here, and some example that we're going to go through. So we're going to try and split these up into two chunks of equations and two chunks of examples here. The instance that we have written out here, and then the instance that we have written out here. We do have some subtle differences between these and some other variabilities that we can see, but this is by and far the two main types of equations where extraction of roots or the square root property is going to come into play. So let's go ahead and take a look at some of these. Starting off with our first example, we are going to begin with using just the first step in our process. We want to isolate the quadratic term to one side. The quadratic term is always the one that has the something squared showing up in that, so we're trying to get this whole term by itself. The way we're going to do that is we need to get rid of this 40 on that side also, so we need to add 40 to both sides. After doing that, we should get to our result here. From here, we move on to our second step. We are going to eliminate any coefficient in front of the quadratic term. So we have this coefficient of 2 showing up here. That 2 is attached through multiplication, so I undo that with division. So I'm dividing both sides by 2. And I'm getting to x squared equals 49. At this point in time, that now because I have the squared thing all by itself, I can now take the square root of, oops, it's a little bit cleaner here. I can now take the square root of both sides of this equation. On the left side, I'm going to be left with an x. On the right side, because I took the square root and I brought that into play, I need to include both the positive and the negative potential answer that shows up here. So in this case, I have that x could equal possibly a positive 7, and it could equal a negative 7. There's nothing in the problem that indicates that we can or can't have one of these, or we need to have a only positive answer or only negative answer. So at this point in time, we can say our final answers are x is negative 7 and x is positive 7, and we are good to go. Looking at our second example, we're still going to go through and solve this thing the exact same way we did our first one. So I want to get my quadratic term isolated on one side, so I need to get rid of this plus 4 over here. So I'm going to, whoops, glitching out here a little bit. There it goes. So I'm going to be subtracting 4 from both sides to make that happen. And then left with 1/2 t squared is equal to 20 on the right hand side. I now want to get this t squared all by itself, so I need to get rid of this 1/2. Undo 1/2 by multiplying by 2. So if I'm going to do that to the left side, I have to do that to the right side as well. I'm then left with t squared is equal to 40. Can't do anything else from there, and now I have my quadratic term all by itself. I need to get rid of this squared attached to it. This is where I'm going to apply the square root property, and I'm taking the square root of both sides. On the left side, I'm getting t. On the right side, turns out that 40 isn't a perfect square, so I can't do a whole lot with it for now. But I do need to remember that because I took the square root, I need to have the plus and minus in front of that square root of 40. Now, if your instructor is asking you to rewrite this as a decimal, at this point in time, you would want to enter this square root of 40 into your calculator and then write that out as whatever that decimal is going to be. I think it's going to be something around 6 point, and then you're going to have some decimals after that. If you were asked to write it out using radical notation, similar to what we were doing in Chapter 9, you would then need to go through and do what we did previously, which is determine the prime factorization of 40, like we did previously. and we determine, okay, I've got a perfect square showing up here. I have a 2 squared, which means that I'm going to be getting t is equal to plus or minus 2 square root of 10. So somewhere nearby, we want to write out for ourselves our answer is 2 square root 10 and negative 2 square root 10. Again, make sure, depending on what your class and your instructor in that problem is asking you, maybe you need to write it out in this form. Maybe you can just use a calculator and write it out as a decimal instead. Make sure you're double checking that before you log your final answer with that accordingly. Our final example for the first set of examples that we're going to take a look at has us working with n squared plus 9 equals 0. So like we did with our last two examples, we want to get the squared term, the quadratic term, all by itself. So I'm going to do that by subtracting 9 from both sides to get rid of this constant term. I get a result, of n squared equals negative 9 from there. It's at this point in time that I would start taking the coefficient and get rid of that, but it already has a coefficient of 1 sitting here in front, that little invisible 1 there. So I don't need to do anything with that, and I can go right to my third step, applying the actual square root property. So I'm taking the square root of both sides. On the left side, I'm getting n squared. On the right side, I'm getting positive and negative square root of negative 9. Now, if we look at this, I'm taking the square root of a negative number. I cannot take the square root of a negative number and get a positive or even 0 or real answer showing up out of this. I would end up getting I and some kind of an imaginary answer showing up with this. Now, most problems and most instructors are going to have you stop here. So this is where we'd say I would, right pen here, I would have no real solution. Again, it's always good practice to take a look at the problem you've been given, more often than not a story problem, and see when we go through and check our answer and say, does this make sense in the context of the problem? And in the context of a real world example, it wouldn't make sense for us to have an imaginary answer. So again, we're listing no real solution as our answer for this particular problem. So now we're moving on to our second set of example problems. We see that the problems are getting a little bit more advanced and that our quadratic term has a little bit more going on with it. We now have something that is adding or subtracting inside of a set of parentheses. Now it's not going to change a whole lot of our process, except it is going to add one or two things showing up at the very, very end, but we'll go through our same process and same steps that we used previously. So first and foremost, I want to isolate the quadratic term to one side of this equation. Basically, I want to get this set of parentheses and the squared all by itself on that left side. So I have no coefficients in front here other than an invisible 1. I have nothing adding or subtracting at the very end of this thing either, so I have this quadratic term isolated to the left side of this equation, exactly what I wanted. I have no coefficients in front of it, so again, don't need to do anything with step 2, and now I can go right to step 3 and apply the square root property. So I'm taking the square root of both sides of this equation, and on the left side, I'm going to be left with the thing inside the parentheses. So I'm going to have r minus 3 left over. On the right side, because I am taking the square root and I am bringing that into play, I need to include the positive and negative answers of what's going to show up here. Now 25 is a perfect square, so the square root of 25 is just going to be 5. And now I have this instance where I have r minus 3 is equal to the positive and negative 5. From here, we have two options. We can either work with it by leaving this plus and minus sign in there, or we can break this apart into two separate instances because we are going to have two answers showing up here. The first instance is where I have r minus 3 equaling a positive 5, and the other one is where I have r minus 3 equaling that negative 5. And now I solve each of these individually. So it turns out that no matter which one I'm using, I'm going to be adding 3 to both sides of the equation either way. For the left side, the left one, I'm getting r is equal to a positive 8. And for the other one, I'm getting r is equal to negative 2. And here we have two answers showing up. It worked perfectly fine there. So make sure when you get to the step where you have that plus or minus showing up, make sure you are splitting that up into our two potential answers as necessary. We tend to have problems where we need to do these extra sets of steps showing up in this particular type of quadratic equation. So we'll take a look at a couple more that are similar to this, but for now, for question 1, our final answers are r equals 8 and r equals negative 2. Working through our second example in this set, we're going to follow the exact same process that we have for all of our previous ones. We want to isolate the quadratic term all on one side, so I need to get rid of this plus 4 over here. So I'm subtracting 4 from both sides of this equation. I'm getting a result of the quantity a minus 5 squared is equal to 20. And then looking for and noticing that I don't have any coefficient out front here. I just have the invisible 1 that's always out there, which is great. So now I can jump to step 3, and I can apply the square root property. So I take the square root of both sides. And on the left side, I'm left with a minus 5. On the other side, I have plus or minus the square root of 20 left over. Now at this point in time, 20 isn't a perfect square, but I could go through and I could rewrite this thing to get rid of and simplify the radical down. In the process of doing that, using everything that we learned from the chapter 9 material, this would break down into being 2 square root 5. Now I still have that plus and minus showing up in front there because I did take the square root back in our step that we had right up here, so that isn't going away. However, we're noticing that square root of 5, it's not going to be a perfect square. If I were to actually take the square root of that, I'm going to get some big, gross, terrible, horrendous decimal showing up. So for this problem, we're going to leave this 2 root 5 in there, and we're not going to really do anything else with it. So to get this a all by itself, I'm going to end up adding 5 to both sides of this equation. So what I'm getting now is I'm getting a positive 5 plus or minus 2 square root of 5. From here, again, it depends a little bit on the question and your instructor, what they're asking you to do, but you could either leave your answer in the form that we have it here, just as a plus or minus 2 square root 5, or we could separate this out to be a is equal to 5 plus 2 square root of 5, and a is equal to 5 minus 2 square root of 5. If you're using an online resource or online program as you're going through and solving these things, a lot of those tend to want this split answer that we have showing up here at the very end. But again, it should be noted that these two answer forms are the exact same thing. Just make sure you're checking what the specific program or test or homework or whatever your instructor is asking you to do. Looking at example 3, we're going through and solving it using the exact same method that we've done up till now. So I want to get my quadratic term, meaning everything inside this set of parentheses all by itself. So I'm going to subtract 10 from both sides of this equation. On the left side, I'm going to be left with the quantity 2t minus 8, all raised to the second power, and that's going to be equal to negative 10. I don't have any coefficient in front of this set of parentheses, because that's really what I'm looking for. Don't let this 2 inside of the parentheses distract you. I'm always looking for the coefficient out front in my second step. So because I don't have any coefficient out front, I can now take the square root of both sides of this equation. On the left side, I'm getting 2t minus 8. On the right side, I'm getting plus or minus the square root of negative 10. Now, again, I am taking the square root of a negative number. I cannot get a real answer from that. So, from here, because I can't get any real answer, I would be putting no real solution. Or no solution from here. Either one works. So this one looks like we could do more with it because the left side has that 2t minus 8. But as soon as we get to the point of us having imaginary answers showing up, more often than not, that's where we can stop and just say no real solution, and then we're done. So here we are at our final example. And this is one that looks very different from everything else that we've done up till now, primarily because we have a squared or quadratic term, and we have a linear term showing up in here. Now the way this thing is currently written, I can't actually use the extraction of roots or the square root property method to get to my final answer. I actually have to take a minute or two and look at and rewrite this whole left side of the equation. As I'm looking at it, I'm noticing the first term and the constant term that we have here are perfect squares. I also notice that this term in the middle is the same as saying negative 2 times the square root of the first term and the constant term, which tells me that this is the square of a difference. This is particularly a 7.4 term and methodology and way of rewriting these things that's showing up here. So I can rewrite this into being x minus 3, all raised to the second power, equaling 12. And from here, now that I've rewritten this, I can now actually use the extraction of roots property to get to my answer. So I'm going to take the square root of both sides. And on the left side, I'm getting x minus 3. On the right side, I'm getting plus minus the square root of 12. Now I can rewrite and reorganize this square root of 12, and that can become and be rewritten into 2 square root of 3. 12 breaks down into 4 times 3. The square root of 4 gives me 2, and so I can bring that out front. Now from here, again, I'm going to leave this plus minus in here for now because this whole thing is just going to be really big and gross and terrible as a decimal. So I'm going to be adding 3 to both sides, giving me my final answer of x being equal to 3 plus or minus 2 times the square root of 3. And like we saw with the previous example, maybe you're required to split this up into one instance where I have 3 plus 2 square root 3, and one where I have 3 minus 2 square root 3. Just make sure you're checking the problem or with your instructor as to which answer form they are looking for as you get through and finish this problem up. So bringing everything back together at the very end here, we have a quick recap of what we went through for 10.1. Again, it's one of our methods that we have for solving a quadratic equation for a given value or something that we need to solve for. Should also be noted that, again, this method is fairly niche in its applications. We have only 2 primary starting places that we would like to use, or when we should really be using this, or 2 setups that we have here. We had our process that we went through. If you need to, again, I'd take a moment to pause the video and write these steps down for yourself, as well as making a note that we might need to do some rewriting of special products into the square of a sum and square of a difference as necessary. The process for factoring those and our quick shortcuts for those were referenced in our 7.4 material as well. And then we went through our 7 examples that we had here. So we'll scroll down and give you the opportunity to pause the video here if you'd like some additional practice to give these a try before we jump to the answers at the very end here. Now with all of these, they are designed for you to be able to use the extraction of roots and square root property. So when you're looking at this problem that we have here, maybe we look to see if we can rewrite that at all before we actually get to using and applying the square root property. If we scroll down, here we have our final answers. So that's everything that we have for the 10.1 material, how we go through and use the extraction of roots.